everyone. Welcome to the video lesson for Thursday, April 29th and Friday, April 30th. We didn't have that much new stuff to go over today. I took some time to go over the example problems from our notes, so we didn't quite have enough time to get to on Monday and Tuesday, but they are in the Monday and Tuesday video. We had a warm-up, and then I let you work on finishing your gizmo and to begin working on your next checkpoint, which is all about calorimetry and specific heat. Today's warm-up was in the same style as your checkpoint. I've given you a calorimetry problem. I've given you all the values you need in that problem, and then I'm asking you to organize it to set it up like the equation. So my big suggestion was to copy all of this and paste it onto a new page in your guided note packet in your Google Slides, so then you can highlight and reorganize it there and then find the correct answers in the quiz warm-up. So let's go through this. I have a 250 gram piece of brass. Well, 250 grams, that's a mass, so I'm going to change that color to blue, is heated to a temperature of 100 degrees Celsius. Temperatures are purple. The hot metal is placed into 75 grams of cool water. Well, that's another mass, so that gets turned blue, at a temperature of 25 degrees Celsius. When the metal and the water reach thermal equilibrium, the final temperature is 36 degrees Celsius. The specific heat capacity of my water is 4.18 joules per gram per degree Celsius. So that's my value for CP. So now I just need to fill this in, and oh no. Well, the first thing I have is a mass, but I've got two masses here. Well, one mass is my metal, the other is for my water. Since I'm solving for the Q of my water, I only care about the mass of my water. So I'm going to take the 75 grams, copy, and I'm going to paste it right there where the M is in my equation. Next, CP, well, I only have one CP value and it's for water, so I can use that. And then my delta T, remember that's final temperature minus initial temperature. I have three temperatures. Uh-oh. Well, let's look at this. Well, the 100 degrees is the initial temperature of my metal. Okay, so I don't need the 100 degrees. The cold water is initially 25 degrees, and at the end, they're both 30 degrees. So my final temperature here is 30 degrees Celsius. Minus my initial temperature, which is 25 degrees Celsius. So if I have 30 degrees minus 25, that means overall my delta T is only 5 degrees Celsius. Now, I also needed something to put here, so Q for water is what I'm actually looking for. So Q of water is X. So now I need to solve for my Q of water. So I just need to plug this into my calculator the same way that I set it up. I have 75 times 4.84 times 5, and I get a final Q value. My Q of water is equal to 1,567.5 joules. That's how much energy my water has absorbed in order to change its temperature by 5 degrees. Then I asked you, what's the Q of the metal? Well, I can't plug it into that equation. I don't have enough information. I don't know what the specific energy of my metal was. But I don't even need to think that hard. I don't need to go through all that work. I don't need to go and look this up. If I know that the Q of my water is 1,567.5 joules, then the Q of my metal is the same, but just an opposite sign. So if my water absorbed that much energy, then my metal released 1,567.5 joules. However much energy one thing absorbs is equal to how much the other one releases. That sign just tells me the direction that it went. If it's negative, it was released. If it's positive, then it was absorbed. So, like I said, for the rest of our class, you went over the notes again. I was available to answer any questions about your gizmo, but then you were also asked to start your checkpoint. Remember, your second attempt for the checkpoint will have opened by the time that this video posts during our Friday support session. Until I see you guys again, make good choices and stay safe this weekend.